today's objective, parallel and perpendicular lines. Let's go over some definitions. Parallel lines, lines in the same plane that never intersect. Perpendicular lines, lines that intersect at right angles. Negative reciprocal, two numbers that have a product of -1. So an example would be 1/2, and the negative reciprocal of that would be -2. And so if you look at that, if you multiply them together, since it says product, 1/2 times -2 is -1. So we definitely know that those two are negative reciprocals of each other. Vic number 1. If two non-vertical lines have the same slope and different y-intercepts, then they are parallel. All vertical lines are parallel to each other, and that, as you can, if you think of that visually, that makes sense. Vic number 2. Two lines are perpendicular if their product of their slopes is -1. That means that their slopes are going to be negative reciprocals of each other. A vertical line and a horizontal line are also perpendicular, and that makes sense. All right, let's tell whether each pair of equations are parallel, perpendicular, or neither. So let's look at these two lines. Y equals 4x plus 3/4, and y equals -1/4 x plus 4. So the first thing we're going to do is we're going to identify their slopes. That's step 1. So the slope here in the first line is +4, and the slope here in the second line is -1/4. So the slopes are negative reciprocals of each other. Therefore, the lines are perpendicular. Okay. Lines, example number 2. Line y equals 2/3 of x minus 6, and y equals 2/3 of x plus 6. So remember, our first step is we're going to look at our slopes. The slope here in this line is 2/3, and the slope over here is 2/3. So if you notice that they have the same slope, different b's, so the different y-intercepts, therefore, if the slopes are the same and different y-intercepts, then the lines are parallel. Lines number 3, or example number 3. Let's look at these lines. 3x minus 5 equals 3. -5x plus 3y equals 8. So let's put those lines into slope-intercept form first, so that helps us identify the slope. Okay? So this line in y equal form is y equals 3/5 of x minus 3/5, and the second line is y equals 5/3 of x plus 8/3. So let's look at the slopes. We can see that this one is 3/5 and this one is 5/3. So we definitely can see that the slopes are reciprocals, but remember, for the lines to be perpendicular, those slopes need to be negative reciprocals. So therefore, these particular lines are neither perpendicular nor parallel. Get used to seeing the symbols, perpendicular, parallel. So let's look at this line. So x equals 2 and y equals 9. So we know, looking at the slope, for if I have an x equal, I know that that particular line is vertical. And the slopes for those, remember, always have a 0 on the bottom. We know that those do not exist. For y equals, we know that those particular lines are horizontal, and we know that the slopes there are definitely 0. So what do we know about horizontal vertical lines? Well, if I graph them any which way, we know that those lines are always going to be perpendicular. Okay? Always. Vertical and horizontal lines. I believe that was in Vic number 2, if I'm not mistaken. So let's focus just now, for these examples, on parallel lines. So writing equations of parallel lines. Write the equation of the line in slope-intercept form that is parallel to the given line, and it passes through the given point. So I have this given line, y equals negative 2x plus 3, and I have a point, negative 3, 5. So here is this line. I want to find a line that is parallel to that line, and it goes through this point. Okay? So this point has nothing to do with this particular line. We want to find a line that's parallel, and it goes through that point to this given line. So the first thing we're going to do is we're going to identify the slope. So here I have my slope is negative 2. I can clearly see that in slope-intercept form. So when we're talking about parallel lines, we know that the slope is going to be the same. So here my slope is negative 2. Okay? So now what we're going to do is we're going to plug the ordered pair, negative 3, 5, into my equation, and we're going to solve for b. All right, so we always put in our new slope, and we're always going to put plus b, because now what we're doing is we are solving for our new intercept, because we know with parallel lines, they have the same slope. We don't know what that y-intercept is, so we're always going to solve for our new b. So we use our ordered pair, the point that the line's going through, and we plug that in for the variables. So here is my x-coordinate, which is negative 3, and my y-coordinate is positive 5. So when we plug that in and we simplify, my new intercept is negative 1. So the equation of the line that's parallel to the given line, and it goes through this point, negative 3, 5, is y equals negative 2x minus 1. Example number 2. Y equals negative 2/3 of x plus 12. Then the parallel line that we're trying to find is going to go through 5, negative 3. So remember, first thing, the slope. So here my slope is negative 2/3, and a line that's parallel to this line is going to also have the same slope. So the slope is also negative 2/3. Notice that's where I bring it down. Okay, I'm going to bring it down here. All right, and then this is where we're always going to solve for our new b. And this is where we're plugging in our x-coordinate and our y-coordinate and simplifying and solving for b. So a slope that is parallel is going to have a y-intercept of positive 1/3. Remember here, you got to get a common denominator, okay? All right, so y equals negative 2/3 of x plus 1/3. So this line is parallel to this line, and this line goes through that point. Writing equations of perpendicular lines. So now we got to switch gears. For parallel, we knew that parallel lines have the same slope but different b's. So for perpendicular, we need to switch that. Perpendicular, they have negative reciprocal slopes. So write the equation of the line in slope-intercept form that is perpendicular to the given line and passes through the given point. So same concept, now we just need to focus on the slope piece. So y equals negative 1/3 of x plus 2. And the point that the perpendicular line is going to go through is 4, 2. So if my slope in this equation is negative 1/3, then the slope of the perpendicular line is going to be that negative reciprocal, and that would be 3. So this slope here is what I plug in there when I begin solving for that equation of that line that's perpendicular. And remember, this is the point that that line goes through, so we plug those pieces in, solving for our new b, okay? And once we do all that simplifying, I see that my new intercept is negative 10. So we plug in all of our pieces, y equals positive 3x minus 10. This line is perpendicular to this line, and it goes through that point. Example number 2. Y equals 2x plus 7, and it goes through the origin, the line that's perpendicular. So 0, 0 is the point that's given to us. So the slope here is positive 2, and a line that is perpendicular, that slope would be negative 1/2. Remember, negative reciprocals, okay? So now we're going to plug in the ordered pair into our new equation, and we're going to solve for that b. So negative 1/2 is that slope that's perpendicular, and here is my x and my y for the point that the perpendicular line goes through. Once it's all said and done, it is 0, and so I can see that, and I can see it here in ordered pair form, that my b is going to be 0 because it's going through the origin, and that's my y-intercept. But if you weren't sure and you didn't notice that point as an intercept point, then go ahead and solve. So y equals negative 1/2 of x. We're going to go ahead and put it in slope-intercept form, but this piece simplifies to just y equals negative 1/2 of x. When you don't see a plus or a minus in a number here, you know that it's 0 because that's how that equation form would simplify. All right, last board. I have an example of each type, parallel and perpendicular. So the first one, write the equation of the line parallel to negative 3x plus 4y equals 8, and it passes through the point 4, 1. So here we have it in standard form, so we definitely needed to transpose it and put it into slope-intercept form to help us identify. So y equals 3/4 of x plus 2. I see my slope is 3/4, so a line that has a slope that's parallel is going to be the same. So my slope is going to be 3/4. Okay? We're going to start in by plugging the ordered pair that was given to us, 4, 1, and in order to put slope-intercept form, remember we're going to have to solve for a new b. So same slope, y equals 3/4, and so here, I get that information here, and so the point 4, 1 that was given to me. So remember, we're solving for a new b. So when I plug everything in, I see that my y-intercept is negative 2. So that equation of the line parallel, this equation, is y equals 3/4 of x minus 2. All right, now let's switch. Perpendicular. Okay, so here's my equation in standard form. The point that the perpendicular line is going through is 8, negative 2. So let's take this standard, solve it in slope-intercept form. Y equals 2x minus 9/2. So the slope here is 2, but the line that is perpendicular, that slope is the negative reciprocal of 2, which is negative 1/2. So this is what we use to plug in. So I wrote here, okay, so we put right there. Remember, we're solving for our b. So the point that they gave us is 8, negative 2. There's my x and my y to finish the equation so I can solve for b. Once everything is simplified, I see that my y-intercept is positive 2. So y equals negative 1/2 of x plus 2. That line is perpendicular to this line, and it goes through that point.